In the previous video, we looked at calculating the slope of the line between 2 points. In that video, we were looking at a generic x and y axis, which may be a little bit abstract and probably doesn't have a whole lot of application in terms of engineering. Today, what we're going to do is we're going to look at the way to calculate a slope given an x and y axis that actually contain units. So we'll answer a few questions about the line in order to understand the concept. Now let's take a look at our problem. What we have here is we have a graph where we're looking at number of hours plotted on the x-axis versus number of miles plotted on the y-axis. You can see that we have 3 points on our graph. After 3 hours, our car has traveled 120 miles. After 6 hours, it's traveled 210 miles. And after 10 hours, it's traveled 270 miles. What we want to do is we want to answer 3 different questions about this graph. The first question says which part of the graph, either R, S, or T, represents the hours when the car moved the slowest. When you say something like moved, you're talking about velocity. All of these questions are going to be dealing with velocity of the car. Part B says what is the slope of part R of the graph. You could also say what is the slope of part S or part T, and you could calculate the slope of either one of those. They're all going to be different. And part C says what is the speed of the car in part R. Part B is talking about slope, but in this case slope is velocity. So part B and part C are asking the exact same question, and I'll show you how we get to that when we start discussing the problem. What you should do now is pause the video, try to answer part A, part B, and part C, put it in the comments below, and then as I go through the solution, you can come back and you can check your answer, make sure that you understand how I got each one of those. The first question here is which part of the graph represents the hours when the car moved the slowest. In order to do that, we're going to calculate slope, because again, the slope of this graph is velocity because we're looking at miles per hour. So if you recall back to slope, it's just rise over run. So it's the y units divided by the x units. So in this case, the y units are miles, the x units are hours. So we're talking about miles per hour, which is a velocity, which will give us the speed. Let's just calculate the slope of part R of the graph. In this case, we have 2 points. Our first point is that x equals 0, y equals 0. Our second point is that x equals 3, y equals 120. If you go back to the first video and you remember how to calculate the slope, we're just looking at rise over run. So to go from the first point to the second point, how many y units do we have to go up? Because the first point starts at 0, the second point is at 120, then we have to rise 120 units, or 120 miles. And how far do we have to run? Well, we have to run from 0 to 3. So we have to run 3 units, so 3 hours. The slope for part R is 120 miles divided by 3 hours, which is 40 miles per hour. R is 40 miles per hour. So we can do the same thing for part S. How far do we have to rise to get to our second point? So I'll label this 1, 2, 3. So how far do we have to rise? Well, we have to go from 120 to 210. So 210 minus 120 is 90 units, or 90 miles. And how far do we have to run? Well, we have to go from x equals 3 to x equals 6. So the same as we had before, we're running 3 hours. So 3 units on the x-axis is 3 hours. So this is 3 hours. This is 90 miles. So in this case, for part S, our slope is 30 miles per hour. Because 90 divided by 3, 30 miles per hour. Same thing for part T. For part T, we're going from y equals 210 miles to y equals 270 miles. So in this case, our rise is 60 miles and our run is from x equals 6 hours to x equals 10 hours. So it's 4 hours. So for part T, our slope is 60 miles divided by 4 hours, which is 15 miles per hour. If we go back to the first question, which was which part of the graph, R, S, or T, represents the hours when the car moved the slowest, we would compare the slope of R to the slope of S to the slope of T. So R is 40 miles per hour, S is 30 miles per hour, and T is 15 miles per hour. So the answer to part A is T equals 15 miles per hour is the slowest part. You can also just look at the line, because a line that is horizontal has a slope of 0, and a line that is vertical has a slope of infinity. So whichever one is closest to horizontal is going to be the lowest slope, or in this case, the lowest speed or lowest velocity. Just by doing that, now we also answer part B and part C. So part B says, what is the slope of part R? The slope of part R, we already have as 40 miles per hour. So the answer to part B is 40 miles per hour. Part C says, what is the speed of the car in part R? Well, the speed of the car, we've already discussed, is the slope, so the speed of the car in part R is also 40 miles per hour. Just by calculating the slope of each one of these lines, you've already answered A, B, and C. Go back, double check your comments, make sure you came up with the correct answer to part A, B, and C, and if you didn't, go back and review the video, make sure you understand what you did wrong and how to fix your mistake.